Hi guys, welcome to this first session or video lecture of chemistry. My name is Aarav, and I'm just going to be walking you through this on paper second chapter, but ideally it's the first real chapter that you'd cover in high school. So I'm just going to go through it once, and as you can deduce from the name, it's atomic chemistry. So it's the study of everything at a really minuscule scale. So we're gonna start by learning what an atom is. I'm sure you've heard the word, but perhaps the meaning is not clear enough. Um, right. So the concept of an atom is basically that it's the smallest possible particle of a chemical element that can exist. Which means that if you take an element and keep splitting and splitting and splitting, up until you reach a certain point where you cannot split anymore, ideally speaking, that would be your atom. That would be your smallest possible component of this element. And most, if not all, of chemistry just revolves around studying how this functions. And at a if you can understand how things function at a very small level, you can generalize that to cases of, let's say, a greater magnitude. And this is where it's going to help you. Right. So now this slide basically tells you what an atom comprises of. And again, these are words that you're familiar with, but perhaps it's something that you haven't studied extensively. You just have heard these words flung around here and there. So there are three main constituents at this level. So you have protons, neutrons, and electrons. And as the properties of the table will tell you, your protons have a relative mass of 1, right? So it's not 1 gram or any specific unit of measurements. It's always a relative mass, and therefore we say 1 unit because it depends on how many atoms you're taking. If you're taking one, or if you're taking a mole of them, which you're going to learn about in further chapters. But for now, we basically say this is the relative mass. And charge, obviously, maybe you can tell from the names itself, but protons are positively charged, neutrons are they have no charge, they're neutral, and electrons are negatively charged. And as you can see in the mass here for electrons, it's 9.1 into 10 raised to the power minus 31, which is really small. So what we do is that for all practical purposes, we can ignore electrons. Therefore, they don't contribute to the weight. Maybe if you take like tons of them, if you take like, let's say, the entire Earth and every single electron on Earth, that would surely have a mass. But for all calculations and for all properties relating to the mass, we can ignore them. That is allowed. Next, this is something that I want everyone to read about after this. It's really interesting, and sometimes when concepts are given to you, you don't really appreciate where they're stemming from. And the idea is that this wasn't the first model of the atom, which we'll also study in this session itself. There were many different models, and one of them was the plum pudding model, which you can see on your screen right now, which was basically that there was this big blob, and all the particles inside would just float around and knock each other. And there was a very nice way of disproving this, which was actually called the gold foil experiment. And I encourage you to read about this. It's really interesting. And depending on which syllabus, they may or may not ask you questions about this, but it is definitely something that you should know. Next, we study the structure. This is the main structure. This is not any historical structure. This is the one that we still follow, and this is still being studied till date. But ideally, this is the basis of what they study. So we studied about the constituents, which are protons, neutrons, and electrons. Now, how are they arranged? Remember, we said electrons, we can safely assume that electrons have no practical mass. So the main mass is contributed to by protons and neutrons, each with a relative mass of 1. And these are all bunched up in the center, as you can observe in the diagram. And now what happens is, because of the weight, kind of like the Earth's gravity, except not exactly that. This is a very heuristic explanation. Uh, Again, scientists are still studying this, but the idea is that because all the weight is centered around there, it has a pull, and that is where the electrons are in these orbits called electron shells. Because of the pull of the nucleus of the atom, the nucleus being the center where all the protons and neutrons are stored. Because the pull, these electrons revolve around this very nucleus, and this is the structure. Um, this is quite an important diagram. There are multiple ways to depict this, and this will be done further when we do bonding. Next, elaborating on the electron shells part, each shell has a specific capacity. Now, of course, it's chemistry, so there are exceptions, but there is one general rule. And the idea is that each of these shells has a specific number of electrons that it can accommodate. And it runs in this series called 2, 8, 18, and there is a general formula, but the idea is that each can only accommodate so many electrons. And why this is important, I can't really completely explain without delving into more complicated aspects. But there is a limit to how many electrons you can shove in one electron shell. And another concept that I'd like to introduce is the concept of stability. So an atom is stable if its outermost shell, that is the most outward, like the most exterior um, located shell, has either 2 or 8 electrons. These states are called two-plate and off-plate states, and they're special because at this point we can say that the atom is stable. What does that mean? It means it won't easily react with other elements unless you apply a really high temperature compared to others. Basically, it's inert. It's a void. And this is again something that's going to be elaborated upon, but for now it's important to just grasp the concept. Next, this is sort of a revision from what you must have done in school. It's basically the differences of elements, compounds, and mixtures. And the idea of an element is that all the atoms are basically of the same type. So they're all one kind of atom. It comprises of only a single kind of atom, and there is no constraint on size as such, but the mass has to be constant, and you can't actually separate the atoms easily as compared to a mixture, as you can see in the table there. Next, we have compounds, which is basically two or more types of elements. So you have two. What is an element? An element is made up of only a single type of atom. A compound is made up of two or more elements. And these are all chemically bonded together. Chemically bonded being a key word to be emphasized upon. This basically elaborates on the difference between compounds and mixtures, because mixtures can be physically separated because there's only um, a physical, it's not a bond, but for the lack of a better word, there's just a physical connection, so to say. So the main difference lies in what is chemical and what isn't. Lastly, I'd just like to cover some definitions, and these are sound like big words, look intimidating, but they're really simple. We're basically applying the concepts that we learned about protons, neutrons, and electrons, and based on their numerical properties and based on their existence, there are some definitions that are important to know. The first is isotopes. These are atoms of the same element that have the same number of protons yet a different number of neutrons, right? So convince yourself of this, take a minute to go through the definition. It's the same number of protons, which is the same proton number, yet a different number of neutrons. Now the proton number, reading it out, or the finding out the neutron number, it's all there when we actually go ahead and interpret the periodic table. But for now, this is an important definition. And so you can see from the example there. Another definition that is pretty relevant is, I would say, isobars, which are basically atoms of different elements, being K, so there's a distinction, which have the same atomic mass. Now, this doesn't necessarily mean they have the same number of protons and neutrons. It just means that the total of the protons and neutrons, the total mass, which is mass of protons plus mass of neutrons, is the same. So you might get a question where you're given three quantities and you need to find the fourth through this definition. And to start off, that is pretty much it. These are the very, very basic bedrock ideas of chemistry, and they're slowly going to build up on them. If you have any questions, you can leave it down in the comments. You can always approach us through social media. Any questions, shoot them right at the Knowledge Unbound email. And that's it for today. Thank you.